Hi everyone. So for this session, we're going to deal with the second conic section, which is parabola. So for this session, we're going to have the introduction part and then the math experiment, parts of the parabola, and some solving cases. Now, after that solving cases, I am going to end this session video and continue it with another one for the word problems and some extension activities. So let's start. So we have here on the screen our satellite dishes. I think you are very familiar with the satellite dishes, wherein they can be used to get signals for radio, for TV, even for internet connection, right? So we use this satellite dishes. Sometimes they are called parabolic antenna or parabolic dish. Now, for our first activity, I would like you to get a piece of paper, preferably a bond paper for the mathematical experiment. So this is what you're going to do. So you have to draw a bold horizontal line, approximately an inch from the bottom of the paper. Create 10 to 12 evenly spaced markings on the line. Fold the paper backward along the line. So if you have the bond paper, you just have to let the markings show. Now, make sure that the markings are evenly distributed, because if they are not, then we might not be able to get our target. Second, draw a point approximately 2 inches above the line. So as you can see, these are the markings here, okay? And then we folded this part right. So we have removed that part already. And then we have point F here, which is approximately, so it doesn't have to be really that accurate. So approximately 2 inches above the line, and label it as point F. Next, fold the paper such that the marking on the line is directly above point F. So if you have these markings, okay, you just have to write no directly or fold it wherein this marking here, okay, will be above the point. Do not exit, okay? It's better if you're going to have it consistently that way. And then before you unfold it, you have to um, press the side, the folded side, okay, before reopening. So you will see how those folded sides may look like afterwards. Repeat this for all the markings on the line. Next, after folding for several times, the curve of the parabola shall start showing. Highlight the curve form. So you're going to see this one. We're in this one here, the dotted lines, or what we call the broken lines, are actually the crease or the folded part. Now, on above those folded part, you will actually see a figure and highlight that figure. That figure will now show a parabola. Now measure up. This is the next part. Draw points A, B, C, D, and E anywhere on the curve of the parabola. So let's say this is the points that I draw. So they don't have to be symmetric. They don't have to have the same distance from the point or whatsoever. You can just put any points around that parabola. Now measure it. You're going to measure two things. First, you're going to measure from point F to the point that you have drawn, okay? So that means you just have to get the distance from point F to the point that you have drawn. Now use centimeters. Use centimeters in writing it down. Next, measure the perpendicular distance from point A to a perpendicular point on the horizontal baseline. Note your measurements on the table. So this will be your table wherein you have to measure 10 times, because for each point, you have to measure 2. Distance from point F and distance from the line perpendicular to it, okay? Next, once you've done that all, you can actually write this table on the free space of your parabolic of your folded paper, so that you will not need any more additional papers. Okay. For the submission, please take pictures of your folded work and table of values. Submit through Orange app. This one is already posted in your Orange app, so you just have to go to Orange app and look for the post where it shows the 10 pictures or the instructions on how to do the work for this activity. Let us now have the part wherein we're going to discuss the second conic section, which is parabola. Now, the word parabola came from the word para, means alongside, and bole, which means a throwing. When we say parabola, it is actually a set of points wherein in the plane wherein it is equidistant from a fixed point. Again, it's again equidistant from a fixed point, and that fixed point is F. And that fixed line is called the directrix. So if you want to go back to the figure that we had a while ago, so this actually shows the focus and the directrix. So F is the focus, and this line below here is the directrix. Let us now have the next part, which is the parts of a parabola. So this is the main part of a parabola, which is the focus. Okay, so after the focus, we also have the directrix, and then the parabola itself, and then at the bottom of the parabola, or however the parabola would look like, that the in between the focus and the directrix is the vertex. Okay, we call that the vertex. Next, a line drawn, okay, passing through the focus and the vertex is what you call the axis of symmetry. And then we also have the latus rectum. Now let me discuss each part. When we say vertex, this is actually the midpoint between the focus and the directrix. Okay, so since it is the midpoint, then it tells that from the vertex to the focus and from the vertex to the directrix, you should have the same distance. They should be divided equally. Next, we also have the focus, or the axis of symmetry rather. So for the axis of symmetry, this is a line passing through the focus and the vertex, which divides the parabola into parts, into two equal parts. Now, if you're going to fold your parabola through that axis of symmetry, you're going to you'll see that the left side and the right side would have the same figure. Next, we will have now the latus rectum. Now, latus rectum is sometimes called the focal diameter. Now, this focal diameter gives us the width, okay, of the parabola, which is along the focus. Again, the width of the parabola along the focus. Therefore, it passes through the focus. So, since we already know the parts of a parabola, let us now have ways on how are we going to get the parts of a parabola given the graph, given the equation. And actually, we're going to have it the other side wherein you are given the equation, and then we'll identify the parts of the parabola and even its graph. So let us look at the first figure. This is a figure wherein you have a parabola which faces upwards. Okay, its opening is upwards. Now you have markings there: 0, P, 0, 0, and y equals negative p. What are these? P is actually a number or a rational number, okay, wherein it could be positive, it could be negative, it depends on the figure, it depends on the parabola itself. Now, if you have a parabola which opens upwards, it gives us a value of p in the focus as positive. Now look at this one. If this is positive, then when it comes to our directrix, it will now become negative. Okay? This is another figure wherein the parabola is upside down. That means our parabola opens downwards. The opening faces downwards. So what will happen? Still, the focus would have an x or an x coordinate of 0, but this time our y coordinate will now be represented by negative p. Why is it negative? Because it is below the origin, since our vertex is the origin. Okay, then of course, those values above the origin will now be positive. Therefore, our directrix will now have an equation which is y equals positive p. This is now the general information that we may get when it comes to parabola, which opens upward and which opens downward. Okay, so the equation that we follow is x squared is equal to 4py. Focus has 0p. Directrix is y equals negative p. Endpoints of the latus rectum, which is positive negative 2p and p. Why do we have positive negative there? Remember, our latus rectum has two endpoints. Therefore, if we're going to interpret this one, this has actually 2 points. One, positive p, and the other one is negative 2p, p. Okay, so those are the two endpoints. And of course, the length of our latus rectum will simply be 4p, because from the focus you have 2p and another 2p, combining it you have 4p. So what will now be the difference when it comes to a parabola which opens downward? Now you just have to look after the sign, that's all. If in upward, you have x squared is equal to 4py, if your parabola faces downward, then you're going to have negative 4py. Again, negative 4py. Therefore, the focus now will be 0, negative p. Directrix will be y equals p. End of latus rectum and the length of the latus rectum would just be the same. What's the difference that we got? It's the sign of negative of the focus and of the directrix, and of course the equation itself. This slide now will show us the other kinds of parabola that we may encounter. So we have two, a parabola that faces to the right and a parabola that faces to the left. So what difference does it have with those parabola that faces upwards and downwards? A while ago, if you remember, the equation of parabola that faces upwards and or downwards will have x squared. And that means your quadratic term is x. And then you have either negative, positive for py, wherein y is the linear term. Okay, but for a parabola that faces to the right or to the left, you're going to have a different set of equations. So what the equation will be? The equation will now be y squared is equal to 4px. So this time, you see that our quadratic term is already y. Okay, but the form of it would still be the same or more likely the same as with those parabola that opens upwards and downwards. So you have here y squared is equal to 4px. Where in the focus, a while ago, focus will have a 0 value for the x coordinate and p. This time, since it opens to the left or to the right, our point is now along the x-axis. Since it is along the x-axis, that is what we call the x-intercept. So x has a value while y will become 0. That's why you have p 0. Then directrix, just the opposite sign of the x-coordinate of the focus. So you have negative p. But this time, our equation is no longer denoted by y. It was now denoted by x since our point or our directrix passes through the x-axis. So we have x equals negative p. Then the endpoints will have p, positive negative 2p. So nagbaliktad lang sila. Kanina, positive negative 2p, p. Ngayon po, p, then positive negative 2p. So it is not really that hard to understand. Kaya lang, it's kind of confusing sometimes because you might interchange it or switch it. Okay, length of the latus rectum is 4p still, so it won't change. Now, for the left side, for the parabola that faces to the left, you're going to have y squared still, but of course, your numerical coefficient for x will be negative. So automatic yun. Y squared, tapos negative yung numerical coefficient ni x. So ibig sabihin nun, yung parabola natin, nag-face siya sa left. Okay? So for the focus, you have negative p, 0. Directrix is positive p since our focus is negative p. Endpoints of the latus rectum is negative p, positive negative 2p. So sign lang po ang pinagkaiba. And length of the latus rectum will still be 4p. For us to understand this more, it's better if we're going to have examples of how to get these parts of a parabola. So to generalize, these are now the cases: upward, downward, x squared, x squared. Left and right, y squared, y squared. Okay. Then you have 0p, 0 negative p, 0 positive p, 0, and so on. You don't have to memorize this. You just have to understand them and see, or you have to check some patterns that you can see later on. Let's try to discuss these patterns that we have seen in these given cases. So for the first example, let us now identify the parts of the given graph of a parabola. So what will be given is the graph itself. And then from that graph, we will identify the parts. So let us start with the first example with this figure. So again, our vertex will always be 0, 0. So you don't have to worry if our vertex is not on that position because we're not going to deal with those topics anymore. So vertex is at 0, 0 and focus is here. Now, first things first, you have to identify or locate the focus of the given parabola, and from there, we derive the standard form of the equation. Okay? So, looking at our given parabola, since it is along the y-axis or the point is on the y-axis, therefore, the value of x will be 0, and the value of y is 2. Therefore, our focus is at 0, 2. Taking note that our opening is upwards, okay? So that would give us actually an easier way for us to determine how are we going to identify the rest of the parts of the parabola. So f is at 0, 0p, so you have 0, 2. That's what is said a while ago. And then our equation for this one is x squared is equal to 4py. So how do we do that? You only have to substitute p with 2. Since our p value, isn't it, this is 0p, therefore your p is equal to 2. And since p is equal to 2, you only have to substitute. So you have x squared is equal to 4 times 2 times y. So x squared is equal to 8y. Okay? Next, let's have the directrix. When it comes to directrix, you only have to get the opposite sign of, yes, P. So if P in the focus is 0, 2, then your directrix will just become negative 2. But question, should it be y is equal to or x is equal to the given uh, the given P value? Since our point lies along the y-axis and the directrix passes through the y-axis, then you're going to have y is equal to negative 2. Second to the last, ends of the latus rectum, you have positive negative 2p, comma, p. So you only have to multiply p with 2. So you have 4, positive negative 4, and positive 2. So I will show you that part of the graph, okay? So for our vertex, it's here. And that vertex is actually 0, 0. Okay, we're aware of that already. Okay, next, focus is at 0, 2. Our directrix here is y is equal to negative 2. And then these are the two latus rectum, the endpoints of the latus rectum. There should actually be a broken line here that shows the latus rectum, wherein you have 2 points. This one is negative 4, 2, and this one here is positive 4, 2. Okay? Wherein the whole length of the latus rectum will now be 8 units. That's it for our first example. Very easy, right? Let us now have the second set. We will now be identifying the standard form given the focus. So this time, you are given the focus. So how are we going to identify? Sandali nga lang. Paano ko malalaman kung upward yun or downward yun or to the left or to the right? Okay? Remember, the focus itself could readily give you what type of or what cases of parabola you have. Like on this case, you have 0, negative 4. 0 si x. So kung 0 si x, yung negative 4 na focus ay nasa y-axis. Teka lang, kung nasa y-axis siya, so ibig sabihin, ang parabola ko pwedeng nakaharap pataas o nakaharap pababa. Okay? Pero negative siya eh. So kung negative siya, ibig sabihin nun, ang parabola ko ay nag-open siya downward. Okay? So with that, we will be using the formula x squared minus 4py, wherein your p value will be equal to 4. Okay? Ma'am, bakit hindi negative? Remember, that negative sign is actually for the position of the point. Now, the p-value will always be positive. Again, the p-value will always be positive. Therefore, substituting it, you're going to have x squared equals negative 4 times 4y. So, x squared is equal to negative 4 times 4. Negative nga. Tama. Downward. Negative 16y. And that is the answer that we have. How about this? Example 3. You have negative 140. Ma'am, iba naman to. Kasi ang 0 ay nasa y-coordinate. So, ibig sabihin, you either have a parabola that opens to the left or opens to the right. And negative siya. That means it opens to the left. Since it opens to the left, marking our p-value to be 1/4, ay paano yan? Fraction, favorite number ko. So, paano ko isosolve yun dun sa equation? So, substitute lang natin. So, you have y squared is equal to negative 4 multiplied by p, which is 1/4 times x. Now, this is a whole number and a fraction. When it comes to whole number and fraction, you only multiply the whole number to the numerator and copy the denominator. So, if I am going to show it in detail, that will be negative 4 over 4x. And when you have 4 over 4 or a number divided by itself, that is actually just 1. Okay, so instead of writing negative 1x, I am now going to write negative x. And that is the final answer. For this part, we will now be identifying the parts and the graph given the standard form. Ay, ma'am, ngayon, mag-graph na tayo. So, please prepare your Desmos. You can actually use other programs or graphing tools that you are comfortable with. So, for example, 4, you have x squared is equal to 4y. O, tingin tayo, x squared. So, kung x squared siya, either upward or downward siya. Right? Okay, so next thing that you have to do is to identify your P. So, dahil downward yung opening natin, then we can say that x squared equals 4y, x squared is equal to negative 4py. That is actually the general form, that should be positive. X squared equals 4py. So, ibig sabihin, meron akong 4 equals 4p. Eh, kailangan ko lang yung p. So, divide ko muna ito ng 4. Cancel. So, p is equal to 1. Since I already know the p value, now it's easier for me to identify the rest of the parts. So, next, let's have the equation. P is 1, as indicated. Then, the p value is, or the focus is 0p. So, you have 0, 1. For the directrix, you have negative p, y is equal to negative p, so you have y is equal to negative 1. And then endpoints of the latus rectum is positive negative 2p, so that will be positive negative 2, 1. And for the length of the latus rectum, that will just be 4p or simply 4. Now I am going to share with you on how are we going to graph this parabola using Desmos. So let us now graph the equation given a while ago. So we have here y is equal to negative 8y. So let us graph y. So let us now graph the given equation a while ago. So this time, let us now have x squared is equal to 4y. So we're going to graph it using Desmos. So you have x squared equals 4y. Okay, so we have our parabola there. But how are we going to identify the rest of the parts? So we're going to just put them manually. So for the focus, we know that it is 0, 1. So we just have to write 0, 1. Then put the label. So we have to write F. Next, we'll have the directrix wherein you have y is equal to negative 1. So that is the directrix. Next, we also have the endpoints of the latus rectum. So we're going to plot them separately. So we will have positive 2, 1. And let's have this as latus rectum 1. And latus rectum 2, which is negative 2, 1. Label it as latus rectum 2. So L2. This is now our graph for the equation x squared is equal to 4y. So for our last example, we have y squared is equal to negative 8x. So since our equation gives us a quadratic value for y, that means our parabola either opens upward, to the left or to the right. Now, with this, since it is negative, then we can say that our parabola opens to the left. So again, getting the value of p, let me just show you the solution. So you have negative 8 is equal to 4p. We divide both sides by 4. So p is equal to -2, but -2. But again, I have mentioned a while ago that for p value, it will always be positive. That negative sign will only just indicate the position of the focus and even the direction of the parabola. So since the opening is to the left, our equation will give us a value of 2 for p, wherein our focus will now be at -2, 0. Okay, since it is to the left. Now directrix, x is equal to p this time. So you have x equals +2. It should be opposite the sign of the one in the focus, wherein the endpoints are at -2, positive -2p, and you have -2, positive -4. And the length of our latus rectum is 8 units. So to solve for to graph, okay, I will I will minimize this one and open the Desmos. Okay, so let us create another new blank graph. So you have y squared is equal to -8y. So y squared equals -8y. Oh, -8x. We should correct that. I am going to move. Okay, so everyone will be able to see it. Next, our focus is at -2, 0. Label F. And then the directrix, x is equal to +2. Next one, latus rectum, you have -2, 4. Let us name this as L1 or latus rectum 1, and +2, 4, -2, -4. This is now latus rectum 2. Okay. And that completes our graph for the second item. To conclude our session for today, I am now going to leave you with some questions to ponder. So, number one, how can you easily identify the value of P? In your own words, how can you differentiate the equations of parabolas that open up or down and the equations of those opening left or right? What solving tips or patterns can you share in order to easily identify the values for the parts of a parabola? So I'd like you to go to your Orange Apps accounts and post your own view of the following questions, and you may actually interact with your classmates through there. So for our try this, I would like you to answer the following. Though I want to correct this one, this should be y is equal to 1/4 x squared. This is 1/4 x squared, and x is equal to 12y squared. Ma'am, how's that? You have 1/4 x squared, but you don't have a numerical coefficient on y. So how are we going to solve for p? You can actually cancel out 1/4. or cancel out 12 for y squared. So how to do that? Then you may check on your lessons in a junior high school on how to do it. But for more tips, you may actually search through the internet. So I will be posting these problems in the Orange app. You only have to answer them. And then after the given time, you will be prompted when to go back for your synchronous session for the discussion of these problems.